Now, let's move on to a more difficult example, multiple LEDs. Here, you will be given a breadboard, an Arduino board, 6 jump wires, 3 LEDs, red, yellow, and green, and 3 220 ohm resistors. You are now required to wire up the 3 LEDs similar to how you wired the LED in example 1. The connecting diagram is shown here to help you. The schematic diagram is also shown here. From the schematic diagram, you can see that the 3 LEDs are connected to 3 separate digital ports from the Arduino board. The red LED is connected to digital port 13. The yellow LED is connected to digital port 12. And the green LED is connected to digital port 11. Note that the returning wires for all LEDs are first connected to the bottom of the breadboard and then using a single wire to connect it back into the ground port, meaning the 3 LEDs are connected in parallel. The code is on the left. Copy and paste the code into your Arduino IDE and upload it to your Arduino board. If you have done everything correctly, it should look something like the pictures on the right. The LEDs should turn on one at a time. First red, then yellow, then green. Besides using the previous code, we can also use this code instead. This code is much simpler and shorter. This is because loops are used to simplify the previous code. Now, let us move on to the next example. Example 3, fade LEDs with AnalogWrite. First, recall that LEDs are digital devices and therefore should only have 2 states, high or low, or simply in this case, on or off. Therefore, it is rather strange that LEDs can be dimmed or faded. In order to achieve fading in a digital device, an LED, we need to use pulse width modulation, PWM. On an Arduino board, only certain pins can do pulse width modulation. These PWM-enabled pins are usually indicated using a wavy line symbol. In order to complete this example, you will also need the following hardware, including an Arduino board, an LED, a 220 ohm resistor, a breadboard, and 2 jump wires. Now, let us explain what is pulse width modulation. As we have just mentioned, LEDs are digital devices, and therefore it can only be in 2 states, on, or known as high, or off, known as low. Here, you are shown a graph of time with the on-off state of the LED. The LED is first off as there's no voltage provided. Then, it was turned on when a voltage was applied across the LED. Then, it is turned off when the voltage is cut. In the graph, times flow from left to right. Therefore, it is impossible to dim an LED by lowering the voltage. This is not allowed, as LEDs can only have 2 states, on or off. Instead, you can dim an LED by switching it on and off very quickly. This is known as pulsing. The pulsing is so fast that the human eye will not be able to perceive the pulsing, but only sees the LED becomes dimmer because less time is used to turn on the LED, and the LED looks less bright. Pulse width modulation can control the brightness of the LED by controlling the percentage of time that the LED is turned on during the time when the LED is perceived as turned on. With larger gaps between each pulse, the LED will be perceived as dimmer, while if there is less time between each pulse, the LED will be perceived as brighter. Here, we can see the schematic diagram. It is very similar to example 1. However, in this example, the LED is plugged into pin 11 instead of pin 13. This is because pin 11 can provide pulse width modulation, while pin 13 cannot. Now, you're provided with the code to example 3. Similar to previous examples, copy and paste the code onto the Arduino. If the circuit is connected correctly and the code is uploaded properly, then you can see the LED gradually being brighter and then gradually dimming in a cycle. Moving on, here is example 4, analog in, out serial. In this setup, you are provided with a potentiometer. A potentiometer is basically a voltage divider or variable resistor. It has 3 terminals: the positive, the negative, and the middle terminal, which is the voltage divider. In this setup, when we turn the joystick of the potentiometer, we can control the brightness of the LED. For this example, you are given an Arduino board, a potentiometer, an LED, a 220 ohm resistor, a breadboard, and 5 jump wires. Now, you are provided with the schematic diagram of this setup. The potentiometer, as previously explained, has 3 terminals. The 5-volt terminal is connected to the 5-volt pin. The negative terminal is connected to ground, while the voltage dividing terminal is connected to A0, an analog in pin. The A0 pin will detect the amount of voltage. On the other hand, the LED and resistor setup is similar to previous examples. The resistor and LED is connected to the PWM enabled pin 9 on the positive terminal, while the negative terminal is connected to ground. In this setup, the A0 pin will detect the change of voltage from the potentiometer, and the digital pin 9 will control the pulse width to the LED accordingly to control the brightness. Here we have the code for example 4. The sketch is rather long because the sketch has to be designed to detect the voltage change from the potentiometer and also control the pulse width supplied to the LED to control its brightness. Next, in example 5, we will have a push button setup. In this setup, you are provided with an Arduino board, a push button, an LED, a 220 ohm resistor, a 10,000 ohm resistor, a breadboard, and 6 jump wires. The aim of this setup is to keep the LED off, but it will turn on the LED when the push button is pushed. If the finger lifts away from the push button, the LED will turn off immediately. Here, we have the schematic diagram for the setup. The push button is connected to the 5-volt input and then to the D2 digital pin. At the same time, the D2 pin is connected to the 10,000 ohm resistor. It is connected parallel to the LED with a 220 ohm resistor. The LED is then connected to the D13 digital pin, and both of the parallel circuits is connected to ground. The code for the setup is presented here. There is something special about this setup because the digital pin D2 is an input pin, which is used to detect if the push button is pushed, while the pin D13 is an output pin and provides voltage to the LED to turn it on.
This is the end of the video. Thank you for watching. Please give us a like and subscribe to our channel. Click on the tab to watch the next part of the video series.